Dear participant, my name is Bollard Azani bin Yahya from National Defence University of Malaysia. Today, I would like to present my research titled High Tensile Concrete Bollard using Macro Synthetic Fiber. First and foremost, let me wish you all good day and welcome. The usage of the bollard is very important in protecting building. It can prevent vehicles from passing through to the building. The aim of this research is to develop the high tensile bollard using a composite concrete with macro synthetic fiber. What is bollard? A bollard is a short post designed to guide traffic and protect from vehicle intrusion. Bollard can be manufactured and installed to withstand significant vehicles impacts, but they can also be used as visual barriers. Bollards also have decorative elements to complement building and landscape design. Throughout history, bollards have been used in many applications, including road or boundary marking and mooring posts. Bollards are still used to manage vehicle traffic and protect pedestrians, buildings, and landscapes. Due to increased frequency and danger of malicious attack on commercial and government buildings, there is an emergent need to protect important structure. The primary threats to buildings and infrastructure is a terrorist attack carried out with vehicles borne improvised explosive device. Why bollard? The primary design objective is to save the life of those who visit or work inside the building in the unlikely event that an explosive terrorist attack occurs. In terms of building design, the first goal is to prevent progressive collapse, which historically has caused the most fatalities in terrorist incidents targeting buildings. Beyond this, the goal is to provide design solution which will limit injuries to those inside the building due to impact of flying debris and air blast during an incident, and also to limit harm to innocent civilians near the building perimeter. This is the example of the concrete bollard design. Why microsynthetic fiber in the mix of concrete? Macrosynthetic fibers are typically used in structural concrete as replacement for nominal bar or fabric reinforcement. It does not replace structural steel and cannot be part of the design in accordance with these Eurocodes. However, macrosynthetic fibers can be used to provide the concrete with significant post-cracking capacity and hence can be used in some design based on plastic analysis, such as for ground-supported slabs and for rock support using spray concrete. In this research, the use of microsynthetic fiber in concrete is to enhance the performance of tensile strength for the structure. This figure shows the macrosynthetic fiber. This is the example of synthetic fiber. On the left side, consider as a microsynthetic fiber, and on this right side is actually the macrosynthetic fiber. This table shows typical synthetic fiber properties. The first objective of this research is to determine the compression and tensile strength of reinforced concrete with macrosynthetic fiber bollard, and the last objective is to determine the effect of bollard subjected to blast loading. The methodology consists of literature review, materials preparations, sample preparation, lab testing, and also field blast testing. Literature review. This section shows the literature review of the bollards. Literature review of the bollards continue. Now, the literature review about macrosynthetic fiber. Literature review on macrosynthetic fiber. Continue. Analysis and result. This is materials and sample preparations. A length of 45 mm macrosynthetic fiber being used into the design of concrete grade 30. The concrete being designed using DOE methods. This video shows how the macrosynthetic fiber being put into the mix of concrete. This is the samples of Bollard. This is compression test. This is the table of compression test result. According to the table, concrete mixed with additional 0.5% macrosynthetic fiber give the high value of compression, which is 39.48 Newton per millimeter square. The additional compressive strength of 25% shows the macrosynthetic fiber contributes to the strength of the concrete. However, the amount of macrosynthetic fiber cannot be more than 0.5% because the compressive strength starts to decrease. This video shows the tensile test. This table shows the result of tensile test. According to the results, concrete mix with additional macrosynthetic fiber give the additional value of tensile compared to the control sample. It shows that macrosynthetic fiber contributes to the tensile strength for the concrete. The properties of fiber itself act as a tensile enhancement materials. However, looking at the practicality, concrete structure needs to achieve the design compressive strength. This picture shows the field blast test using an explosive. Let's look at the field blast test video. This is the observation from the result of the blast test. The control sample have small cracks but not damage. The composite concretes using 1% of macrofibers have no cracks and also not damaged. The Bollard with 2% of microfibers have crack and small damage. But the Bollard with 3% of microfibers have cracked and totally damaged. Conclusion. In comparison of the result, 0.5% of macrosynthetic fiber in concrete give the higher compression strength. Also, it offers the enhancement of the tensile strength. For the field blast test, the maximum of 1% fiber show no crack and no damage of the bollard. As a conclusion, concrete mix with additional 0.5% macrocytic fiber is the optimum content for the concrete bollard. Ladies and gentlemen, thank you for your time. See you again. Bye bye.